today we'll be wrapping up most of chapter 10 here with lesson 10.6, solving factored equations. The goal is to solve equations that are already factored for us. So some information we'll need is up here in red. If m times n is 0, then m equals 0 or n equals 0. So, for example, if two numbers are multiplying and we know they multiply to equal 0, one of those numbers has to equal 0, right? One or the other. Well, this is going on with variables, right? If we have one variable, 6 times x is 0, we'll divide by 6, well, x has to be 0, right? But what if we're foiling and we have like x plus 1 times x minus 2 equals 0, right? We're going to set each piece equal to 0 in order to solve. So that's kind of going over this sentence right here. So to solve a factored equation, we set each parentheses equal to 0. So, example, we've got x plus 7 times 2x minus 1 equals 0. To set x plus 7 equal to 0, it looks like this. X plus 7 equals 0. Pretty straightforward. So that's a pretty quick equation to solve as well, because then I'm just doing my opposites of PEMDAS, right? Add or subtract away from the x. So subtracting 7 from both sides, I get x. 1x equals minus 7, and there's one of my solutions. 1, yep, now we have 2x minus 1. The other parentheses also could equal 0, right? And so we're going to add away from the 2x. So opposite of minus 1 is adding. So we add to get 2x equals 1. And now dividing both sides by 2, because I want 1x, opposite of multiply is divide, I get x is half. And so I got two answers. X can equal -7 or half. And so those are my two answers. I actually technically have both of those numbers will make the equation 0. So we're going to do a bunch more of these, and then we'll move on to some that have 3 variables. So first, solving x plus 4 times x minus 3 is 0. Again, x plus 4 equals 0, and we'll solve, and then x minus 3 equals 0 and solve. Now, some of you may realize that there's a little bit of a pattern here. Don't take it to heart, but it's okay to notice the pattern. We have 1x plus or minus a number. So in this case, on the left, I subtracted 4 from both sides. X is minus 4. On the right, I'm going to add 3 to both sides, and I get x equals 3. So x equals minus 4 or 3, and I just like to put those together so my answer is not as spread out. X equals minus 4, comma, 3. Next one, x minus 6 times x plus 9. X minus 6 equals 0. X plus 9 equals 0, right? Both parentheses equal 0. Opposite of minus 6 is plus 6 to both sides. So x equals 6. Opposite of plus 9 is minus 9. So x equals minus 9. My answer is x equals 6, comma, minus 9. Two different numbers, separated with a comma, so it doesn't look like 6 minus 9. We'll do a couple more where our numbers aren't necessarily always x plus or x minus. And then we'll also look at what would it look like if we had 3 parentheses. Process does not change. 2x minus 1 equals 0. And solve. Now these will take 2 steps. Same thing with 3x plus 4 equals 0. So opposite of minus 1 is plus 1 to both sides. 2x equals 1. Then we divide by 2 on both sides to get x is 1/2. Now, because I know there's another parentheses, I'm going to put a comma, and I'll put my next answer next to it. 3x plus 4 equals 0, and now we're subtracting 4 from each side, right? You should always give us a kind of an egg of a 0. 3x equals minus 4. Divide by 3, because we want 1x. We get x is minus 4/3, and I'm going to rewrite that nice and neatly over here so that my answer can be boxed. Right? Next problem, 5x minus 7 times 2x minus 6 is 0, and I'm already rushing to write each piece equals 0. Not necessarily rushing, but that's the process. Set them equal to 0. Plus 7 to both sides to get 5x equals 7. And 2x minus 6 plus 6 to both sides, 2x equals 6. Normally we solve one at a time, so I'm getting a little 2 at a time here. So divide by 5 on both sides, x equals 7/5. I prefer it in fraction form, so I could plug it back in right here to see if it would work, right? That's a way to check, plug it in, divide by 2 on both sides, x equals 3, and I'm just going to put that right next to my 7/5. And again, if I plug 3 in here, 2 times 3, which is 6, minus 6 is 0, check. 5 times 7/5, the 5th would cancel, so I get 7, minus 7 is 0, it works. One more set and we'll move on. Now we got 7x plus 3, 3x minus 9 is 0. And try this on your own and then check your answers once I'm done. So my answers are 7x plus 3 equals 0, minus 3 from both sides, and divide by 7 to get minus 3, 7. And the next one's going to be 3. 3x minus 9 is 0, plus 9 to both sides, and yes, you need to show this work. Divide by 3 from both sides, and 9 over 3 is 3, so x is 3. 8x minus 11 equals 0. 8x is 11 by adding 11 to both sides, and then divide by 8. And so I get x is 11/8, and then 9x plus 2 is 0. Subtract 2 from both sides, 9x equals minus 2, and then divide by 9 on both sides. Do not lose a negative sign, but minus 2/9. And those are some different answers. Next, we'll move on to ones that have 3 parentheses, or 3 pieces, more important. X times 8x plus 4 times 2x minus 1 equals 0. So in solving, when there's 3 numbers, if they still multiply equals 0, x could be 0, 8x plus 4 could be 0, or 2x minus 1 could all be 0. So we're still going to do the same process of setting each piece equal to 0. Now, technically, I don't see a parentheses around x or even 2x in the next problem. However, treat them like they are there. So, for example, x equals 0. Okay, that wasn't really a solving process, but that is a potential option. X could equal 0. Now we're going to bring the 8x plus 4 equals 0 down. Minus 4 from both sides, divide by 8, and we'll get minus half. Make sure you simplify where you can. And so far I've got x equals 0, minus half, right? This 0 came down, by the way, that was actually an answer. And then 2x minus 1 equals 0, plus 1 to both sides, 2x equals 1, divide by 2, x equals positive half. And so our answers are 0, negative half, and positive half for this. Next one, 2x equals 0, well, x is 0, right? Divide by 2, half of nothing is still 0. X minus 3 equals 0, plus 3 to both sides. X is 3, and x plus 3 equals 0. We're running out of left to right space. Minus 3 to both sides. X is minus 3, and we've got 3 answers. Put them all together, so I'm not playing find the answer. And there's our answer, 0, plus 3, minus 3. Now, application. Where would I need to use this? What's the point of all this, right? Is typically these problems, right? So we know how to factor, right? Maybe we didn't necessarily have every type of factoring we've seen so far, like the 3 groups. However, we know how to factor from our earlier lessons. So this is where it comes into play, right? And it seems like each lesson we're kind of adding a piece to the equation, right? First, we were learning how to do diamond problems when we didn't have to divide by 8. Then we learned how to do them where you do have to divide by 8. And now we're learning what was the point of splitting it up, right? The point of solving these factor equations, or even just in general quadratic equations, like we were doing before, we used to do quadratic formula. Right? That was kind of a long, lengthy process, and sometimes the answers weren't nice, and sometimes they were. Well, factoring is a quicker process for solving. So, for example, 1 times 12 is 12. And add equal minus 8. Well, that means both numbers are negative. I get a minus 6 minus 2. Because it's 1x squared, I don't really need to do this divide by 1. that I'm doing in dotted lines because they aren't going to change, right? 6 divided by 1 is 6, and in this case, minus 6. Negative 2 divided by 1 is minus 2, right? So we get x minus 6 times x minus 2 equals 0. And now we've seen these all day in today's lesson, and you just set each piece equal to 0. X minus 6 equals 0. Add 6 to both sides. X is 6. X minus 2 equals 0. Plus 2 to both sides. X equals 2. So we're going to write that answer over here. And our answers are x is 6 and 2. We just solved a quadratic equation that about a month ago we would have been like, what are we doing? How do we solve? Right? So, one more. 3 times minus 8 is minus 24. Add to equal minus 2. Our numbers are going to be minus 6 plus 4. And this time we do have a 3 in front, an a value. So we're bringing that over. Negative 6 divided by 3 is minus 2. So x minus 2 is one of our parentheses. X plus 4/3, not so much. And so we're going to do the divide, slide divide bottoms up. And this is where the bottom, the denominator, comes up, and we'll get 3x plus 4. And then this whole thing equals 0. And setting each piece equal to 0. X minus 2 equals 0. And 3x plus 4 equals 0. And to solve, we have plus 2. X is 2. Minus 4 over here, and then divide by 3. We get minus 4/3. So x is 2 minus 4/3. Complete the homework that is attached onto Google Classroom that goes with this lesson. And again, shoot any emails to me, Mr. Lacine, by my school email, and I will gladly answer back the questions, possibly during our Zoom time together for class or through email. Thank you.